Question 1. Jumping on a trampoline is a good example of Newton's law of action-reaction because A. As you jump up, gravity brings you down. B. As you push down on the trampoline pushes you back up. C. Gravity forces you down. Or D. You might slip off the trampoline. Question 2. 25 meters per second northeast is a description of A. Velocity, B. Acceleration, C. Speed, D. Distance. Question 3. A baseball player hit a baseball as hard as he could. The baseball player used a large baseball bat that was 10 times heavier than the baseball. Which of the following statements is correct about the moment the baseball and the baseball bat made contact? A. The force received by the baseball is greater because it has less mass. B. The force received by the baseball bat is greater because it has more mass. C. The forces received by the baseball and the bat are equal in magnitude and opposite in direction. Or D. The baseball bat would apply a greater force if the baseball player swings the bat with less acceleration. Question 4. Determine which law is being applied or investigated in each description statement and mark the appropriate answer. A crash dummy is being used to test how fast a human body will travel forward if the vehicle the person was sitting in while not wearing a seatbelt crashes into an object while traveling at 60 miles per hour. A. Newton's law of inertia. B. Newton's law of force and acceleration. C. Newton's law of action-reaction. Or D. All of the above. Question 5. Assume that the box in the diagrams below represents a rocket's engine. Which diagram best shows forces involved in a rocket launch following firing the rocket's engine? Question 6. A plane flies at 600 kilometers per hour. How far will it go in 3 hours? A. 1,800 kilometers. B. 200 kilometers. C. 900 kilometers. Or D. 300 kilometers. Question 7. For an investigation, a student measures the speed of a cart as it rolls down a ramp. The student then records data in the table below. Which of these best explains the student's data? A. The speed of the cart decreases as a cart rolls down the ramp because of the friction between the cart and the ramp. B. The speed of the cart increases as it rolls down the ramp because the force acting on the cart is greater than the force of gravity. C. The speed of the cart increases as the cart rolls down the ramp because the forces acting on the cart are unbalanced. Or D. The speed of the cart decreases as the cart rolls down the ramp because the forces acting on the cart are balanced. Question 8. A toy train engine rests motionless on a track. One student begins pushing the engine to the right with a force of 2 newtons. At the same time, another student begins pushing the engine to the left with a force of 5 newtons. Which of the following best describes the resulting motion of the engine? A. It travels left at a constant speed. B. It travels left at an increasing speed. C. It travels right at a constant speed. Or D. It travels right at an increasing speed. Question 9. 4 students race toy cars on a track. The mass and the acceleration of each car is recorded in the table below. Which toy car had the greatest applied force? A. 1, B. 2, C. 3, or D. 4. Question 10. Sometimes tectonic plates do not move easily past one another, and the plates become stuck. Forces build up, and when the plates finally move, tension is released as shown below. The sudden movement of the plates is caused by A. The mass of the plates, B. The weight of the plates, C. Unbalanced forces, or D. Gravitational force. Question 11. Look at the drawings of a grandfather and his granddaughter on a swing. At which position does the swing have the greatest amount of kinetic energy? A. Position 1, B. Position 2, C. Position 3, or D. Position 4. Question 12. A student walks 3 kilometers in 30 minutes. What is the student's average speed in kilometers per hour. Record your answer and fill in the bubbles on your answer document. Be sure to use the correct place value. Question 13. There are two soccer players running at a ball in opposite directions. One player kicks the ball towards the goal with a force of 35 newtons. The other player then kicks the ball with a force of 16 newtons in the opposite direction. What is the net force on the ball? A. 51 newtons, B. 35 newtons, C. 19 newtons, or D. 16 newtons. Question 14. What is the difference between the speed of a moving object and its velocity? A. The speed of a moving object never changes, but the velocity can change. B. The velocity of a moving object never changes, but the speed can change. C. The direction of motion must be specified for speed, but not for velocity. Or D. The direction of motion must be specified for velocity, but not for speed. Question 15. The graph below shows the distance a student walks down a hall over time. Use the information shown on the graph to answer the following question. During which time interval was the student moving the fastest? A, B, C, or D? A student runs 2 times around a running path at a local park. Each lap is 3 kilometers. The student completes the first lap in 20 minutes. The student then sits on a bench and rests for 5 minutes before completing the second lap in 25 minutes. Which graph best represents the student's motion? Question 17. A student holds a marble at the top of a ramp. She releases the marble, and the marble begins to roll down the ramp. The marble reaches the bottom of the ramp and continues to roll across the floor. At which point does the marble have the greatest amount of potential energy? A. At the top of the ramp before it is released. B. Near the top of the ramp right after it has been released. C. At the middle of the ramp as it rolls down the ramp. D. Just past the bottom of the ramp as it rolls across the floor. Question 18. 2 cars with different masses travel at the same speed down a hill toward a stop sign. What will happen when both cars apply the brakes at the same time to stop? A. The car with a smaller mass will require less force to stop than the car with the larger mass. B. The car with the larger mass will maintain its velocity while traveling down the hill. C. The car with the smaller mass will take longer to stop than the car with the larger mass. D. The car with the larger mass will have less inertia than the car with the smaller mass. Question 19. The diagram below shows a boat moving north in a river at 3 meters per second, while the current in the river moves south at 1 meters per second. How will the boat be affected if it enters a part of the river where the current is moving south at 2 meters per second? A. The boat will move slower. B. The boat will move faster. C. The boat will stop. D. The boat will move to the west. Question 20. A tennis ball has a mass of 0.06 kilograms, and the tennis racket has a mass of 0.3 kilograms. A player hits the ball with a force of 25 newtons. Why does the ball accelerate much faster than the racket? A. The racket is unable to accelerate because the tennis player is holding onto it, while the ball is free to move. B. The ball comes to a stop before it starts to accelerate away from the racket, so there was no force acting on the racket. C. The force of the racket is directed towards the ball, so it is in the wrong direction to accelerate the tennis racket. D. The mass of the ball is much less than the mass of the racket and the player's arm, so the same force causes greater acceleration on the ball. Question 21. The masses of 4 vehicles and the net forces acting on them as they enter a highway are recorded in the table below. Which vehicle has the greatest acceleration as it enters the highway? A. Sedan. B. Coupe. C. SUV. Or D. Truck. Question 22. The graph below relates distance and time for a moving object. What is the average speed of the object represented by the graph above in meters per second? Record and bubble in your answer on the answer document. Be sure to use the correct value. Question 23. Some students measure the acceleration of a wheeled cart being acted on by varying forces. The students record their data in the table shown above. According to the data table, how much force is acting on the cart when the students measure an acceleration of 2.6 meters per second squared? A. 13 newtons, B. 7 newtons, C. 8 newtons, or D. 12 newtons. Question 24. A student lets a toy car roll 4 times down a ramp that is 1 meter long. Each time the student covers the surface of the ramp with a different material. The student measures the time it takes the car to roll down the ramp and records the results in the table below. Which of these would be the best conclusion based on the data in the table? A. Different surfaces affect how fast a toy car accelerates. B. Different toy cars travel at different speeds. C. Gravity has little effect on the speed of toy cars on different surfaces. Or D. Air resistance is the greatest factor in limiting the acceleration of different toy cars.